today's lecture, we're still on the topic of integration, and specifically, we have used the Newton-Cotes formulas. So another form of the Newton-Cotes formula is the Simpson's rule. So what is the Simpson's rule? So if you recall, we have estimated the integral of this graph using linear function. And if the curve is second degree or higher, it will not give you a better approximation. So what we'll do is, instead of a line, you will use a second order or second degree curve. So how will you do that? You need 3 points. Example this one. So if this is the curve, you will now get a much better representation. Okay? So in equation form, the integral will be equal to function. Okay, so if this is the function, we will replace this one with second order curve. Okay, second order, this one, denoted by subscript 2. So what is this f sub 2? The equation that we will use is the second order Lagrange polynomial. Okay, we have not tackled this one. This Lagrange polynomial, but it is equal to no. Okay, x sub O. Since we'll be using 3 points, sub O to x sub 2, integral of, so taas din siya ng formula, x minus x1 okay, so this is the Lagrange polynomial. Okay, medyo taas siya, no? Pero when we evaluate this one, this will become will be equal to h over 3 f of x sub O plus 4 f of x sub 1 plus f of x. Okay, so this will now be your integral, okay, where tanning h, again this is b minus a over 2, and this equation is what we call the Simpson's 1/3 rule. Okay, Simpson's 1/3 rule, because this is multiplied by third. Okay, so the corresponding error will now be equal to negative b minus a raised to 5 over 1080 f of 4 okay the fourth derivative of the function. Again, to evaluate this function, you need to get the integral of the fourth derivative of the function and then divided by b minus a. Okay, it's like what we did for the trapezoidal rule. Okay, so again, let's use this example. Let's use this function and let's test whether Simpson's 1/3 rule will give us better result as compared to the trapezoidal rule. Okay, so according to Simpson's 1/3 rule, the integral is equal to h over 3 multiplied by f of x sub o plus 4 f of x sub 1 plus f of x sub. Okay, so we now have this is our x sub o is 0, x sub 1 is the point between 0 and 0.8. So this is 0.4 and x sub 2 is 0.8. We now have the value of f of x sub o, f of x sub 2, and f of x sub 1, which is of 0.4, is equal to 2.456. Okay, so let's plug these values. Our h is b minus a over 2. This is 0.8 minus 0 over 2 is 0.4. Okay. So if this is our graph, this is our graph. 0.8 and the middle value is 0.4. So we will try to plug in second order degree curve or second degree curve. Okay, so this is our representation. So you have 0.4 divided 3, 0.2 plus 4 times 2.456 plus 0.232. So the integral value is 1.367467. Okay, now we compare this one to the true value, which is 1.640533. So we'll get true error of 16.6%. So this is a much better approximation as compared to the trapezoidal value or trapezoidal rule. Now we will estimate the error or get the approximate error, and we know that the equation is negative b minus a raised to 5 times, okay, to get the fourth derivative of the function, the average value. So what will we do is we will get the fourth derivative of this one. Okay, we'll start from the second derivative, which we derived last time. Okay, so this is the second derivative. We'll get the third derivative. So the fourth derivative is okay. And to evaluate this one, we'll get the average value. Okay, so it's equal to 0.8 of the fourth derivative divided by 0.8 minus 0. This is equal to okay, so in order to evaluate this function, first we get the fourth derivative, and then integrate this one from 0 to 0.8 divided by b minus a, or 0.8 minus 0. Okay, so if we evaluate this integral, this will give you negative 2,400. Okay, so using those values, you have negative 0.8 raised to 5, 2,880 times negative 1,000. So this will give you value of 0.273067. Okay, so you see the improvement in terms of the error. Okay, so just like the trapezoidal rule, the Simpson's warranted rule has also a multiple application, or you can divide it into many segments. So if you have this function, you can divide this one into segments. Okay, okay. Okay, what you have observed is we will end up with an even number of segments. Okay, why even? Because in order to uh, plot a parabola, you need 3 points. this one up to here, another segment, one to here is that one. Okay, with that, you can uh, assume that the approximation will be much better. So the formula for that, the integral value equal to, take note that this is just an approximation, b minus a, as well as the other method, plus 4 summation from, okay, so this is the uh, Simpson's one-third rule for multiple segments. Okay, so you have the summation of f of xi for, this is for odd numbers. And for even numbers, you have f of x sub j. Okay, so let's apply this one from our previous example. Okay, so this is our example. And we know that a is equal to 0 and b is equal to 0.8. Now we will solve this one using multiple Simpson's rule, a multiple application of Simpson's one-third rule, but we will have 4 segments. Okay, so what does that mean is this is 0, this is 0.8. We'll divide this one into 4 segments. So you have 0.2, 0.4, 0.6, and 0.8. Okay, so our target is this one. Okay, and for this one, another segment. Okay, okay, so let's use this equation. By the way, for the multiple application of Simpson's one-third rule, the error, approximate error, will be negative b minus a raised to 5 all over 180 and raised to 4 average of the fourth derivative. Okay, so let's proceed. So our b is 0.8 minus 0 multiplied by f of x sub o. Now our x sub o, this is f of 0, so this is 0.2, and f of x sub 1, that is f of 0.2. So the value for that is 1.2. F of x sub 2, f of 0.4 is 2.456. F of x sub 3, f of 0.6, that is 3.46, and f of sub 4 is 0.8, 232. Okay, so let's plug in this value. So I is 0.8 times f of 0 is 0.2 plus 4 f of x1. So x1 1.288. Since this is odd number, so appeal ang f of x sub 3. So this becomes 4 sub 1 1.288 plus x sub 3 3.464 x sub 5 wala may x sub 5 kay tama na naman og 4. Okay, and then for the even numbers we multiply 2 and then n minus 2, so tama na rin og 2. So that is f of x sub 2 is 2.456 plus xn, which is 0.2, and then you divide this one by 3 times 4. So this will give you a value of 1.623467. So ang atong true value is, remember that our true value is equal to 1.640. So doon lang kayo. Ang atong true error ani would be 1.04%. Okay? Now for the approximate error, again we'll use this function. Negative 0.835 180 times 4 raised to 4 times this one, the average value of the fourth derivative. Nakuha na ito na ganiha, negative 2,000. So the approximate error is 0.017067. So gamay na kaya siya. Okay? Now there is another method using Simpson's rule, which is the Simpson's 3 rule. So unsa pa niya? Simpson's 3 rule is done when you fit a third order degree curve. Okay? So instead of second order, you now use third order Lagrange polynomial. No? So again, same process, trapezoidal and 1/3 rule. We change this one using the third order Lagrange polynomial. We will arrive at this equation. Okay, so this is the Simpson's 3 rule, and to apply this one, you need to have 4 points. Okay, you have sub O. And then we need to divide this one into no. So actually, sobra ni. No? So if naa kay graph, if you want to use Simpson's 3-8 rule, okay, so i-divide mo na siya into 3 segments. No? Okay. So mo na siya. You need 4 points. So, and the error for the Simpson's 3-8 rule is equal to negative b minus a raised to 5 6480 f to the fourth of this one. Okay, so again, to evaluate this one, you get to get the average of the fourth derivative. Okay, so let's apply this one to our previous example. Okay, so this is our equation. So in order to apply Simpson's rule, 3-8 rule, we'll divide this one into 3 segments. Okay, so corresponding points sana niya is that we have 0, this is 0.8, this is 0.8 divide 3, so pila na siya? 0.2667. Okay, so 0.2667 kani 5. Okay, by the way, kaning h dire, since i-divide naman nato ni siya 3, so ang case ani is b minus a over 3. No? So muna na yung difference nila sa 1/3 rule. Okay, so let's plug in the values to this equation. We have I equal to 3/8. H is 0.8 over 3, which is 0.2667. Therefore, H is 0.2667. Okay, 0.2667 times f of 0 is 0.2. F of x sub O, f of x1, f of 0.2667. Ang value anak niya is 1.432. 724. F of x sub 2 0.533 is 3.48177. F of x sub 3, which is 0.8 equal to 0.2. Okay, so the answer for this one will be 0.2 plus 403, 3 combined, 1.432724, 3.487 plus 0.232 divided by over 8 naman. Okay? So, yung nang i-add, we'll get a value of 1.51917. Now, this will give you a true error of 7.4%. So, among the other methods, mas gamay siya error, no? For single application. Okay? So, unsay advantage niya as compared to Simpson's 1/3 rule? So, ang advantage niya ani is kung gusto nimo i-divide ang segment nimo into odd number, no? Kaya ang katong 1/3 rule dapat pares mo siya. Dapat pares. No? Kani pwede add. So, for this example, pwede nimo i-combine ang 1/3 o 3/8 rule, no? Example, i-divide nimo ni into 5 segments. Okay? So, pwede nimo applyan diri og 3/8 rule. Diri, pwede nimo applyan og 1/3 rule. So, pwede nimo i-combine. So, again, nato nakuha ang approximate error. Ang approximate error makuha using this equation. Negative b minus a raised to 5, 6, 4, 80. Okay, F4 of... So again, same equation naman ni siya sa kanina. So nakuha na nato ang value ani F average value of fourth derivative, which is negative 2,400. So you have negative b 0.8 to 5, 480. The approximate error is 0.12. 1212.